Hello everyone, this is DSA Zindabad. Today we are going to solve the 8th question of Arsh Goyal DSA sheet, and the question is to sum. Now let's look at the problem statement. Given an array of integer nums and an integer target, return indices of the two numbers such that they add up to the target. You may assume that each input would have exactly one solution, and you may not use the same element twice. You can return the answer in any order. Now let's try to understand the problem statement, right? Initially, what we'll be having, we'll have nums array, right? Let's say this is our nums array, 2, 7, 11, 15. And there is target value. So what we need to do, we need to find out two elements from this array, two elements from this array, from nums array, such that when they sum up, their sum will be equal to that of the target. This is our goal, right? Now, when we look at this array like 2, 7, 11, and 15, what will be the number which will add up to 9, right? We can see from this, like when we add 2 and 7, then our result will be 9, right? Let's say if instead of 9, if we have something like 13, then what will be our answer? Then for this, 2 plus 11 will be equal to 13, right? And at the end of this, we need to return their indices, right? So 2 element is present at the index 0 and 11 element is present at the index 2. So we need to return this as our answer. So from this, like as we can see, like from this array 2, 7, 11, 15, right? Uh, 2 and 7 will add up to 9, right? So their indices are 0 and 1 respectively, right? So we need to return this as our answer. Now let's look at the second example also. We have given this array 3 to 4 and our target value is equal to 6. So when we add like 2 and 4 and their indices are 0, 1 and 2. So 2 plus 4 is equal to 6, which is ultimately equal to our target, right? So this is our answer. That's why, and their indices are 1 and 2 respectively. So this will be our answer, right? Now let's jump into the approach how we are going to solve this question, right? Let's jump into the approach. Let's take this example 2, 7, 11 and 15, right? 2, 7, 11 and 15, and our target value is equal to 9, right? So what does the, first of all, let's try to discuss the brute force approach and we'll optimize further brute force approach. So we have given this array, right? So what comes in our mind when we say the array? It's something sort of like traversing over the array, like try each and every possible combination and just need to find out which element will be sum up to the target value, right? So what we'll be doing, we'll just traverse over the array linearly. Let's say this is our array, right? And for each and every element, let's say we have this element, and for this element, what we are going to check, we are going to check whether our target will be equal to 9, right? Let's say for this element, we are checking 2 plus 7, 2 plus 11, and 2 plus 15. These are the possible combination, and this will be equal to 9, and this will be equal to 13, and this will be equal to 17. And so from this, we can directly see like 3 is our target. So we are going to return, this is our answer, right? So let's take a different example. Let's say we have this array. Let's say we have this array 16, 8, 23, 4, and 15, right? And the indices are 0, 1, 2, 3, 4. And our target value will be equal to 19. So what we are going to do, we'll just iterate over this array linearly. And for this element, we are going to check uh, like whether we are going to So for this element, what we are going to do, we'll iterate over all the element and try to add all the elements with this element, right? What I mean by this, like, let's say we have this pointer on the first element, which is 16 over there. What we'll be doing, we'll add up 16 plus 8 for this array, and then 16 plus 23, 16 plus 4, 16 plus 15, which will be equal to 31, which will be equal to 20, which will be equal to 39. So as we can see, like, there is no combination from this, which will be equal to our target, right? So we'll move our pointer to the next element. And for now, for 8, well, what we'll be doing, we'll try to add all this element one by one with this element, right? So let's try to 8 plus 23, 8 plus 4, 8 plus 15, right? This will be equal to 23, this will be equal to 12, and this will be equal to 31, right? Since, as we can directly see, none of the element will give us the target output, right? Now we'll move our element to 23. And for this, we'll just try to add 4 and 15. So what we'll be having, 23 plus 4, 23 plus 15, right? 27, and this will be equal to 38. And there is no answer from this since we didn't receive the output as 19, right? So we'll move our pointer to fourth element, right? So 4 plus 15 will be equal to 19, right? This is our target. I hope this approach is clear to all of you guys, like how we are iterating over the array. For each and every element, we try to find out which element from the remaining array will give us the required output, which is the target, right? For A element, we need to find out B, right? So that this will be equal to our target. This is our main goal, right? So now let's try to discuss the time complexity and space complexity for the same. So for this array, we are given a particular array and we are traversing for each and every element 2 times, right? Let's say when we are at this element, right? When we are at the 16 element, so we'll try to make all the possible combination which we have in this area, right? We try to add 16 plus 8, 16 plus 23, 16 plus 4, 16 plus 15, and try to find out whether we are getting a required output or not, right? So we are traversing our loop 2 times. So it will require big of n square time complexity, right? And the space complexity will be equal to big of 1, since we are not using any extra space. No extra space, right? Now let's try to think about the better approach, right? How we can think about the better approach. Now let's try to discuss this thing. Now, better approach, right? Now when we try to think about the better approach, let's say whenever we have array, right? What comes in our mind? First one is traversing, right? And whenever we need to search in a particular array, we came across sorting, right? And after sorting, what we'll be doing, we'll just traverse over the array following some conditions. Traverse over the array following some condition, right? Now let's try, now take the example. Let's say we have this array, which is 16, 8, 23, 4, and 15, right? We have this array. And then there's 0, 1, 2, 3, and 4, right? So after sorting, this array will become something like this. 4, 8, 15, 16, 23, right? Now, how we can traverse over this array? Because we need to find out 2 elements whose sum will be equal to the target value. So this suggests something like we kind of need like 2 pointers for traversing over the sorted array, right? I hope you all get like why we require 2 pointers, since need to find out two elements whose sum will be equal to the target value, right? So initially, our first pointer will be pointing to the this element, which will be, let's say, A, and the B will be pointing to the max element. This is our max element, and this is our minimum element. So after this, what we are going to do, like just need to traverse over the array, and we'll just figure out like we require two pointers. Now we need to think about how we can traverse over the array. Like we just need to find out the conditions, right? Because as I mentioned earlier, we can traverse over the array after like following some conditions, right? So we need to find out those conditions, like how we can traverse over the array, right? Now let's try to think, right? Our target value is equal to 19, right? So first of all, what we are going to do, we'll just initialize a two pointer. A pointer will be pointing to the minimum element, and the second pointer, which is B, which it will be pointing to the maximum element, right? So we'll just try to add both of them, A plus B, which will be equal to 4 plus 23. Now 4 plus 23 is equal to 27. Now we'll compare this result, compare with target value. If our answer is like less than that of the t. Now let's try to visualize this thing, right? Since we can say like 19 is less than 27. This is our target and this is our answer after adding minimum and maximum element, right? So we just need to decrease this value, right? So how we can decrease it? So we need to decrement our maximum element pointer, which is B. B is pointing to the maximum element. So we just need to, whenever our answer is greater than that of the target, then we need to decrement our B pointer, right? I hope like why I hope you all of you get like why we are decrementing the B pointer, right? So that we can approach towards our target value, right? And now let's our B pointer will be pointing to this. Now again we'll try to add this thing A plus B. Now A plus B will be equal to 16 plus 4 will be equal to 20. Now again our 20 is greater than that of the target, same condition. So again we need to decrement our pointer, right? So now our pointer will be pointing to this element, right? Which is B over there. So again, let's say we'll try to add the elements 4 plus 15, which will be equal to 19. Now, whenever we find like A plus B equal to T, so we need to stop and we just need to return the indices of both elements, right? So as we can see, like we find out all the elements, like we find out our answer, which will be equal to the target value, right? Now let's try to discuss the time and space complexity for the same. Time complexity. Since we are sorting our array, so it will require big of n log n, right? And after this, we are just traversing over the array, so it will require big of n. Ultimately, this will boil down to big of n log n, right? And the space complexity would be big of 1, right? I hope this approach is clear to all of you guys, like why we choose sorting and why we require two pointers, all of these things, right? Now let's try to optimize this approach, right? Since its time complexity is big of n log n, so our main motive is to convert the time complexity to big of n, right? So how can we convert our time complexity to big of n? This is the main uh, goal, right? Now let's discuss the optimized approach. Optimized approach, right? So whenever we think like about the big of n solution, what comes in our mind? This means we just need to traverse the complete area only once. Only once. Initially 2, 7, 11. It will have 2, 7, 11, and then we have 15, right? 2, 7, 11, and 15, right? So we need to think of like some sort of like data structure where we can store a particular element. Like let's say we have uh, on this element, so we cannot go backward, right? Since we just traverse our second element, so we just need to store to somewhere else so that in future, if we need this two, so we can directly retrieve this two from some other data structure, right? So for this, what we are going to use, we are going to use hash map, right? Now let's do a diagram like for the same. Let's say we have this array. Let's try to take some different example, right? So now let's take the example, which is 2, 6, 5, 8, 11, and target value will be equal to 14. So let's take our hash map, and hash map store element in the form of key value pair, right? So initially our pointer will be pointing to the start of the array, which is 1 over there. So first of all, we'll directly put the initial element since so for this, what we'll be doing, we'll just need to 2 plus x will be equal to target. So we need to find out this x element so that it will be equal to target. And for there, our target is equal to 14, right? So we'll check whether this x is present in our hash map or not, right? We just need to check whether it is in our map or not, right? Since there is no element in our hash map, so we'll just directly store 2 as it is. Alongside with 2, what will be storing? Its index, right? Since we need to return the index at the end of the day, right? So it will be equal to 0. So now our pointer will be pointing to 6. So 6 plus x will be equal to 14. So x will be equal to 14 minus 6 will be equal to 8. So we'll try to look in our hash map. Is 8 is present in our hash map or not? Since there is no 8 over there in our hash map, so we'll just directly store 6 in our hash map, right? 6 along with its index, which is 1 over there, right? Now our pointer will be pointing to 5. So now what we'll be doing, 5 plus x will be equal to 14. Now x will be equal to 9, right? So we'll try to look in our hash map is 9 is over there or no. Since there is no 9 in our hash map, so we are going to store 5 along with its index in our hash map, which is 2. So now our pointer will be pointing to 8. So 8 plus x will be equal to 14. So now our x will be equal to 6. So we'll look in our hash map whether 6 is there, since like as we can directly see from our hash map, 6 is present over there in our hash map, right? So what we are going to do, we'll just look in our hash map whether this element is present or not. So we are just going to return the index of the two elements, which is 1, and for 8, what is the index over there? It is 3. So we are going to return 1 comma 3. This is our final answer. Right. Let me just write these steps for you. Store in hash map, in hash map, a plus element equal to target. We need to look for element in map. If element is there, then just return indices. Otherwise, keep storing a along with its index. This is current element, right? And this is index of that current element. So these are the two steps. So now let's try to discuss the time and space complexity for the same. So this will, since we are using hash map, so on an average hash map stores all the elements in big of 1. So we are just iterating over the array, so it will require big of n time, right? And since we are using our hash map, so it will require big of n, since we are just storing all the elements in the hash map. So its space complexity will also be the same as that of the time complexity, right? I hope this approach is clear to all of you guys, like why we require hashing, why we are storing each and every element, so that we come to this time complexity, right? So now let's try to code this thing up. And after writing the code, we'll again discuss the time and space complexity, right? So initially, this is for storing the indexes, right? Since we just need to return our answer in the form of vector, right? So we'll use an ordered map for storing all the elements, right? So now we'll just iterate over the nums array, nums dot size, right? So we need to find out if empty dot find, what we need to find out, target minus nums of I is not equal to empty dot end. This means there we find out the index, right? So we just need to push back the index of that element, which is target minus nums of I in our vector. This will be our first index, and second index will be equal to simply I over there. This is for the current element, and this is when we find the element in our hash map, right? And after this, we'll just return the vector. Else, what we are going to do, we are just storing the element equal to I, right? And again, after this, we'll just need to return our vector. Now let's try to run this code. This runs perfectly fine. Now let's try to submit this code. Yeah, this code runs perfectly fine. Now let's try to discuss the time and space complexity for this problem. Since we are just iterating over our array and just storing the elements in our hash map, so it will require big of n. On average, our hash map require big of 1 for storing all the elements in the map, right? So it ultimately our time complexity would boil down to big of n, right? And talking about the space complexity, since we are just storing all the elements in the map, plus we require another vector, so it will be equal to big of n, right? This vector is for storing indices, right? I hope this approach is clear to all of you guys. Thank you so much for viewing the video till the end. Please like, share, and subscribe, and comment if you have any doubt. Thank you so much.